So before starting the IoT-enabled wireless sensor network for agriculture applications, right? First, we will discuss the terms, what that IoT and what is that WSNs, right? IoT, you know that Internet of Things, and WSN is the wireless sensor networks, right? So how that IoT is started and that WSN has started, right? So first we will talk about the WSN, right? The idea of WSN was first popularized by scientists from a university that is called University of Berkeley, right? And they have developed a series of sensor nodes, right? So initially they developed the Mica sensor nodes, right? So that was the first sensor which is developed by the UC Berkeley, right? University of California, Berkeley, and they also developed some softwares, right? Open source software, right? And that name was Tiny OS, right? So these is just used for efficient manipulation of sense data, right? So first of all, they are used for the small interconnected autonomous systems, right? So these are used for submarine warfare that was integrated undersea sound surveillance system, right? So, so it is first developed by the US military in 1950s, right, to detect and track Soviet submarines. Right. So this technology is still in service. Nowadays, we are using these things, right, for monitoring the undersea wildlife and volcanoes activities. Right. So that was the history of that WSNs. Now come to the another part, that is IoT. The concept of IoT first introduced in 1999 by Calvin Hodgson through the Auto ID Center at MIT and related market analysis. Right. So they have used RFID. RFID is a very popular term. I think you know that, right? So it is a radio frequency identification. Right. So RFID generally used for tracking objects and people in our daily life. So similarly, they use that RFID, right? And they use internet, they use computer to manage all collected data or individual things, right? So just like as for example, nowadays we are using the fast tags, right? So what is that fast tag? It is also use the RFID technology, right? So FASTag is a device generally that employ RFID technology for making toll payments, right? Directly while the your vehicle is in slow motion, or right, or it is in on stable condition. So everyone knows the use of FASTag, right? So this is also a RFID technology. This is using the RFID technology for making the payment at your toll plazas, right? So these are the basic terms and history of these terms, right? So in this we will discuss the what is that wireless networks, IoT's networks. Then we will discuss IoT enabled wireless sensor networks. Then type of IoT enabled wireless sensor networks. We will discuss then some hardwares, right, which are available, and applications and characteristics of such networks, then the protocol stack, and then we will discuss some research issues related to uh, IoT enabled wireless sensor networks. Then we have some solutions for that issues, right? Then we will also discuss the future perspective in terms of research for solving some research issues, right? Then we will conclude, right? So first, I think most of you are the student of means BTech or MTech, right? So I think you know that why a network and what is the motive of network. right? Because if we are talking about the sensor network, or if we are talking about the IoT, means everything is related to network, right? So can anybody tell me that means I'm just want to know that what is your background for that, right? So question is that why we use network, right? So any idea, candidates, participants, can you tell me about the network? Why we use network? Anybody can try.
To share the resources.
Yes.
Sir, this is a network of the network, so it's means the local and wide area network connectivity across the world. So
No,
it's
no, no. Just one answer I received, that is used for, means network used for sharing resources or sharing data.
To
yeah,
connect
from one
data.
place, yeah, from transiting data from one place to another.
Yes, but again, one more question. If we have lot of ways for sharing data or transferring data from one place to another place, right? Like we have pen drive, CD, DVD, hard disk, then why network is required?
Sir, for the like domestic or international transiting the data, if we have the transferring data in the small volume from a limited place, like for a particular area, so we can use the pen drive or other hard drive mediums, but the transferring the data from like one continent to another through
Right,
the network, so we need the international transit network, so that's why we need a network of network.
right. That is the correct reason. If we are using CVD, DVD, then there is a limitation of storage. One limitation of storage. Another one is the if you want to transfer data to multiple devices at the same time, so it is not possible using the single hardware, right? But if you are using the network, then you can easily transfer that information to the multiple systems, correct? Similarly,
Yes,
if
sir. Yep.
I want to send data from India to US, it requires long time and it also increase the operational cost, right? Similarly, if we are talking about the input slots, right? So input slots should be available in the computer for hardware connecting, right? If you uh, want to connect any hardware with the computer, then that slot is required, right? Okay, then these are the just categorization of different wireless network, right? So you know that what is wireless network? Wireless network is a network that use wireless connection between network nodes, and that node may be your computer, laptop, anything, right? Then we have WPAN, right? WPAN is a wireless personal area network that use wireless communication technologies to communicate and transfer data between the users which are connected to each other, right? And that WPAN is also known as the short wireless distance network, right? Then we have wireless LAN, right? So a wireless LAN is a wireless computer network that connects two or more devices using wireless communication, right? To form a LAN, right? Just you can say that network may be your home and building and college and office buildings like that, right? Then come to the next, we have wireless sensor network, right? So a wireless sensor network is a network of low size, low battery power, and low complex devices, right? So just we are saying low size, low battery power, and low complex, right? So these devices called sensors, right? And that sensors have self-organizing capabilities, means they have that power, right? Self-organizing capabilities, and they have equipped with sensing, computing, and communication abilities, right? Means they have the power of sensing, they can sense the environment, then they can perform simple computation, right? And after that, some computations, they can transmit that information to the next sensor, right? So each sensor can sense its environment, perform simple computation and communication among its peers or nearby nodes, right? Directly or indirectly. Then after sensing that information, they can forward that information to the sink, or you can say to the base station, right? Directly or with the help of other nodes using internet, right? Now come to the IoT, right? So generally, yes. So IoT is a system of interrelated, interconnected objects so that are able to collect and transfer data over a network without human intervention, right? Because this one is third session, you already know the basic definition of IoT. So anybody can define the basic definition of IoT. What is IoT? Because you already covered two sessions. Okay. So generally, in layman term, we can say, for example, we have some devices, right? We have some devices like we have a computer, we have mobile, we have another objects, right? Means objects or things or any equipment, right? So we have set of devices, right? And we are communicating each other, means these devices are able to connect each other and transferring data and collecting data from each other and sharing that data, right? That is the IoT, right? So now we are considering few examples related to IoT, right? So see this first one, right? So in first one, you have we are just considering a traffic scenario, right? In that we have some traffic cameras. We have deployed some cameras uh, over the road, right? Or some traffic points, right? And they are collecting the information, traffic information from that point and sharing that information to the city-wide monitoring system. It is a centralized center, right? And they are capturing the traffic information and sending that information to that center, right? Using some network gateway or using internet, right? So after getting that information, that center can take a decision to reroute the traffic, right? So this is an example of IoT. So in that you can say we have some cameras, means these are the devices, cameras, and these are just capturing the data from the road, right? And these are just capturing the data and forward that data to the center, right? So based on data information, just centralized system taking the decision of rerouting the traffic for managing the traffic, right? Sorry. Another example is for waste management in a smart city, right? So in that you can see we have different that garbage cans, right? And means some sensors are deployed in that garbage cans. If that garbage cans are full by using that garbage, then they can send that message to the controller, right? And that controller may be on cloud, right? So they can send that information to the cloud. Then after that, that cloud will inform to the garbage truck, or they garbage cans can also send the message to the garbage truck. Accordingly, they can collect the data from the garbage cans, right? So this one is an example of uh, IoT. So come to how that IoT works, right? So initially we have some devices like just we call that things or devices, right? We have some IoT devices, right? So what will be the device, student? Can anybody tell me the name of that IoT devices? क्या हो सकता है IoT device? Do you know the name of any IoT device? A smartwatch?
So Alexis, Siri.
Yes.
I think, sir, all the devices which end user is using that have the sensor to sense
Yes.
yeah.
Like your mobile is IoT device?
Amazon Echo, sir.
Yes.
Alexa,
Alexa.
Alexa
mobile
is
handset
IoT
is also,
device.
yeah, Alexa.
Your mobile phone?
I think, sir, mobile phone is also will cover
Yes,
under
yes,
IoT.
yes.
They have the
Yes,
smart
it is
features.
also a device.
Yeah,
Means
we
every
can use.
device which have some capabilities, right? Sensing the data and sending
Yeah,
and receiving capabilities.
yes, sir. We can use mobile handset as a remote, just like a TV remote or
Right.
so we have the future.
Okay. So initially you have some devices, right? And these devices are capturing some data, right? And they are sharing that data to the gateway, right? Using some wireless network, right? So for example, if we are talking, you have two devices and we are communicating or sharing data between two devices. This is also an IoT part, right? Then they will send that information to the gateway, and gateway will forward that information to the cloud if required, right? If we are not using the cloud, then if we are using the local server, then that gateway will forward that information to the local server, right? And some analytics will be find out by using that data, right? And that after performing that some data analytics, then that whatever decision will be taken, that will be delivered to the user interface, right? So that is the working of how that IoT, right? Then come to the next thing. How does information generated from IoT devices, right? So first one is the act, right? So means it is the initial process. It is just maintain or changing a physical events or their state, right? Second one is the create. So it use the sensors to generate information about the physical events, whatever we want to capture from the environment, right? So it's just use the sensors for generating information, right? Then next one is the communication. So whatever information is generated if in that create, that will be transmitted, right, from one place to another place. That is the communication, right? Then we have the aggregation. So aggregation means aggregating together of information, creating at different time or different sources, right? For example, we have deployed some sensors and we are receiving information from multiple sensors. For example, we have deployed three sensors. right? So what it will do that in aggregation, they will collect that information to a nearby node, right? And that whole information of that nearby node transmitted to the control server or whatever we are using for controlling the things, right? Then after aggregation, we have analyze, right? So after receiving the information, right, aggregated information, just in analyze, it's just discriminant or just the patterns of the data, whatever we received from the previous state, right? And accordingly, we can predict or we can take the decision based on the receiving patterns, right? So that is the complete things of that IoTs, right? So now we will talk about the Internet of Things enabled WSN, enabled wireless sensor network. So in that you can see we have some sensors, right? And we have some devices also, right? And there is a concept of clustering, right? So in that we just divide that some set of nodes or gadgets in a group, right? That is called the clustering. And all the devices in a group will send that information to a single device or single sensor. Then that sensor will transmit that information to the base station or sink, right? So similarly, you can see in that, for example, if we are talking about that particular group, so in that group, that sensor will send that information to that particular device, mobile, right? And that is responsible for transmitting that information to the base station, right? So actually that is IoT enabled wireless sensor network. So in that we have IoT plus lot of sensors, right? And they are just communicating the uh, whatever area we are using, whatever for what application we are using, they will capture the data for that particular application and transmit that information to the base station, right? So we can categorize that WSNs and IoT enabled WSNs into uh, two types. One is the homogeneous networks, another one is the heterogeneous network, right? The homogeneous network means we are differentiate that networks on the basis of the sensor node capabilities, right? So if we talk about in IoT or means we are using the multiple devices, then capability will be different, right? But if we are using the same type of nodes in network, right, sensor nodes in the network, then depend that how you will categorize. So we will categorize that nodes on the basis of energy, means battery, bandwidth, and wireless links, right? So based on that, we can categorize that network. Homogeneous means every node have the same energy, same bandwidth, and the same wireless link for transmitting information, right? But in case of heterogeneous, that thing will be different. Means, for example, if we are using 20 sensor nodes, so in 20 sensor nodes, for example, 4 5 nodes have the uh, 9 volt battery and 5 nodes have 5 volt battery, right? So in that case, we are using the heterogeneous devices in terms of their battery, right? Similarly as for wireless links and similarly as for uh, communication and sensing range, right? So based on that means characteristic, that energy, bandwidth, and wireless links, we can categorize the networks, right? Now we will talk about the hardware platforms, right? So generally that was the first node, WECA, WEC 99, means it is started in 1999, right? Developed in 99. Then we also call that the smart rock sensor, right? So generally it has a small microcontroller, right? And have program memory in kilobytes, 8 kilobytes code for the program memory, and that sensor have 512 bit data RAM. That was the size for RAM, right? So it is used for measuring the strength of any building, right? So these WIC sensor will use, means they use that for uh, find the strength or measure the strength of the buildings, right? So and in that case the data rate was only 10 kbps, right? After that we have if we talk about the latest sensor configuration, right now we have 64 KB RAM sensor or very high data rate now, whatever sensors we have nowadays, right? Then we have dot sensors, right? It is generally used in environmental sensing networking, right? Then we have third Mika 2, right? It is used for security surveillance and force protection environmental monitoring, right? Then we have TALOS mode, right? Modes is also the name of the sensors, means we call that sensor or modes, both are the same thing, right? So generally this offers more than just low power operation, right? So whatever uh, whenever we need to communicate by using low power, then we can use that such networks like in a mass network and the communication implementations, right? So these are the some categories for which we have networks, oh sorry, sensors, right? As you know, we have the sensors for tracking the position, pressure, proximity, right? Proximity means distance, right? So we can easily find that position of any object, right? Presence of any object, right? And proximity of an object. So we have such type of sensors. We call the proximity sensor, right? Right. And that are available in market at very cheap cost, approximately 100 or 150 rupees only, right? We have also motion sensor for capturing the motion, velocity, and displacement, right? So generally, displacement sensor is used to measure traveling range, right, between where an object is and whatever reference object we are considering. We can find the that range, right? Reference object and the real object. Then we have the temperature sensor, right, which is used for uh, measuring the temperature or heat, right? Sorry. Then humidity sensor, moisture sensor. So these are the different type of tasks for which we have sensors, right? We can easily monitor such type of things. Acoustic, sound, vibration. Acoustic sensors used generally for measuring sound level, right? Then we have sensors for chemical and like gases, for measuring different type of gases. If you want to calculate the flow of the water in tap, you can easily calculate. We have also sensors for calculating the flow, calculating the load, torque, stress, pressure, everything, right? We can also check the labels, right? uh, of label of water or anything, or leakage also we can check using some sensors, right? For example, if we are using some gases, right, right, then we can use gas sensor. If it is leaked, then gas sensor will detect it. Then we have electric or magnetic things for, right? Accelerator we can choose. Then machine vision, that optical ambient lights, right? So we have means sensor, lot of type of sensor for capturing the things, right? uh, some specific sensor is also shown. You can see different type of sensor like temperature sensor. So these are the different type of temperature sensors generally used for calculating the degree of hotness or degree of coolness, right? And after reading or measuring that hotness or coolness, they will convert it into the readable unit, right? Then we have the soil moisture and humidity sensors, right? So soil moisture measures the water content in the soil, right? Similarly, humidity sensor detect and measure the water vapors, right? Then we have ultrasonic sensor generally used for distance from the object. For example, if you are using a garbage collector, right? So how you will find that the garbage collector is full through the object, right? So we can put that object, right, ultrasonic sensor, right? Then it will let you know the distance, uh, how much distance we have in a garbage. In that we can put some garbage, right? Means just whenever that distance will be 0, then you can say that garbage collector is full, right? So we can use that. Then we have some speed sensor for measuring the speed of a vehicle or of a object, right? Then we have infrared IR sensor, means infrared sensors generally used to detect obstacles in front of any signal, right? If you are passing a signal between a path, then you can easily track the obstacles. Then we have gas sensor, right? So it is a means LPG gas, methane, alcohol, hydrogen, smoke detector. Like we have different type of gas sensors, right? So generally these are used for environmental monitoring, right? So these are the real figures of the sensors which are available in the market, and the cost is very low. If we are talking about the cost of these sensor, it is approximately 100 or 200 rupees, right? Then applications of IoT enabled wireless sensor networks. So we have home networks, right? Home networks means smart power monitoring for we can use that things means IoT or IoT enabled sensor network for monitoring smart power, right? Security alarms we can use, right? We can also use IoT enabled sensor network for window control, light and door control, right? And we can also use that monitoring the elderly persons, right? In agriculture, we can measure the humidity and temperature, right? Bring out fertilizers, right? We can also find when water is required, right? So such type of things we can use, right? In disaster crisis management, right? Just drop sensor nodes from aircraft over the required area. For example, there is a disaster, right? And we want to get the information from that particular area. So just we can drop the sensor nodes from any aircraft, then they will send you the information, right? Then we have military applications like border control, battlefield detection and tracking, right? Then we have logistic applications like equip goods with the sensor node, right? Whenever we are transmitting something from the logistic, then we can deploy some sensors with that and track their mm, position or whatever we want to check, right? We can easily find out. Then telematics, right? Uh, Telematics or ITS means intelligent transportation system, right? So for traffic controlling, we can use the like while IoT enabled sensor networks, right? Then we have mobile RFID, right? Uh, it is used to connect all the major areas of the city and monitoring and controlling the activities, right? Means that monitoring will be through using the sensor devices, right? So we have many other applications like power transmission monitoring, building energy monitoring, smart roads, right? Like traffic monitoring and accident detections, structural health monitoring. For example, you have a old building and you want to monitor the structure. What is the status of that building? Then we can deploy the structural sensors for that. Then we can detect the gas pipelinings for leakage, right? And some environmental monitoring we can use also, right? Then come to the connectivity, how we can connect the things, how we can connect the devices. So in IoT, without internet connection, there is nothing, right? Because if you have some devices and you are not able to connect that devices, right? So you cannot transmit the information. And if you are not able to transmit the information, means there is no network, right? So that diagram is just indicating the growth of our connectivity type of things, right? So initially we use that uh, power line Ethernet printed, right? So it is just a network of wired devices that are connected, that help in connecting the uh, multiple devices using Ethernet ports, right? Ethernet ports means using the LAN cable, right? In that we use the RJ45 and for connecting the things, right? So that is the Ethernet, right? So it just provide the speed up to 400 Mbps, right? Then we have RFID, then AND, then NFC. NFC means near field communication. Means it is always used for transmitting short range wireless information between the gadgets, right? Then we have 6LOW PAN, right? So 6 is indicating the IPv6 based low power wireless personal area network, right? Then we have Zigbee technology, right? So Zigbee technology, we are also using that technology nowadays. It is a low cost, low power wireless network management. In that we use such type of protocols for transferring information and generally used for battery operated devices, right? Then we have UWB, means ultra wideband, means these are based on the radio technologies, right? Then we have different other networks, right? Like 2G, 3G, 4G, right? Then this is the complete generation of networks which is used for connecting the IoT devices. Sorry. Then in that case, we have considered a scenario in that we are using the transportation and plus a smart city, right? So for example, if you can read the scenario in that Sophia and son are on the way downtown for a appointment, right? So they have visited something, right? And if we are using the smart things, means we are using that sensor networks and we are using the smart parking. So at that time, then wireless sensor embed in the parking. IoT helps direct on car to open sport in the city, right? So just they have come for a appointment, right? Then if we are using the smart parking, then for the parking they will receive a message that parking point is free, right? Then you can drop that car on that particular position, right? After that, if that appointment time is fixed, for example, they will take 2 hours at that place, then they will also use the things, right? Another things means using the car parking details, the vehicle schedule a mobile mechanic, right, to change the oil. If there is a requirement of change the oil, then by using that smart network, they can call a uh, mechanic for changing the oil, right? So in that thing you can see, if you have a smart city and a smart transportation, right? So we can use that things during that appointment, right? Means it will help in your parking, and also you have called for a mechanic, right, for changing the oil. Similarly, in the healthcare and smart home, right? So, for example, any old elderly person is living alone in that particular house, right? So, and in that we have lot many sensors for uh, they are continuously monitoring the activities of the person, elderly person. Means it may be your measuring health activity level, sleeping patterns, and medication schedule. Everything is watching. If there is abnormal in any that thing, then they just inform to the authorized family member, or they can just send a message to the healthcare service, right? So this is an example of healthcare plus smart home. Right. Another example is the smart building plus mobility. Right. So, for example, NI is being pressured to reduce the company expenses for new office. Right. So, NI is in planning to prepare a new office. Right. But she has some limitation of funds. Right. So, after some discussions, right, just after speaking with the experts, right? So C decide to install sensors to automate energy uses, right? So they just deploy sensor network, IoT enabled sensor network. By using that, they can manage that the people flow, temperature, and type of things. Then he can she can manage the cost of the company, right? It can she can use the wastage, reduce the wastage of the companies, right? Then come to the characteristics of IoT enabled wireless sensor networks. In that we have energy harvesting, right? So energy harvesting means WSN supports energy harvesting, right? Means energy generated by external source like solar power, thermal energy, wind energy. It is acceptable by the sensor. It is not fixed. All sensors or any device will always use the battery power, right? So that other power is also acceptable, means that green power we call. Then programmability means that IoT enabled WSN are capable to accept a new set of instructions that may alter the device or network behavior. Then we have cope to node failure, right? Means जो IoT enabled WSNs have ability to copy node failure. If any node is fail, the network has automatically drop that particular node and reconnect with the another one, right? That's why we always use that sensor nodes help self-organizing capabilities. Right. Then we have the mobility. So we have some movable node also. They can capture data in the movable condition. Heterogeneity means they support the such network support the heterogeneity also. Scalability means we can easily add the node sensor nodes, or we can add the devices, or we can remove the devices. Right. So such networks are also scalable. Right. Then capability to withstand harsh environment. So they have the ability, right? Such networks have the ability to collect the data in the harsh environment, right? It is not fixed. If our environment is very much cool, then they just collect the data. Then we have simplicity, right? These networks are very simple. Then cross layer design means in WSN we have designed only techniques which supports all the layer of protocols, right? So generally we can find that generally responsibilities of the layers which are used in the IoT enabled WSNs. So as you know, the physical layer is responsible for transmitting the bits, right? So generally here we will check only the uh, bit error rate, right? So number of bit error per unit time, that is the bit error, right? So physical layer address the need, right? Uh, the simplicity and the robust modulation, right? This is also address the need of transmission and receiving techniques, right? So it can be exploited by both system level or node level, right? In that we need some algorithm for making it energy efficient, right? Then we have data link layer, right? So it is responsible for medium access and error control. Medium access means if we have four devices, right? And four devices are using the single link for transmitting some information, right? So who will transmit first? Means which device will transmit first? That first whatever information they have, it will be decided by the medium access protocols, right? So here we have some issues also, research issues. We can work on the medium access control for mobile sensor networks. So there are limited work done on that, right? Some error coding schemes can be generated, and there are some possibility of generating power saving mechanism, right? Then network layer means network layer is responsible for routing network configuration in presence of node failure, right? Means same thing is that if there is a failure in the nodes, then how they will reconnect, right? Then data aggregation, if two or more nodes are collecting same information from the field, then how they will aggregate that information to transmit that over the network, right? So here we have research issues on that. We can make the system energy efficient, right? Addressing because it support the IP addressing, right? So we will perform how we can propose the new routing techniques. Routings means by using the shortest path we can transmit our information over the network. Then applications means here work is the data management and synchronization, right? Then research issues is like task assignment and data advertisement protocol, right? How we are handling the queries and how they are transmitting the data at the physical the application layer, right? So another is thing is that cross layer issues. So generally cross layer means we are talking about the all layers, right? So we have here the security type of thing, right? So security depends on a CIA triangle. Generally we call that that is confidentiality, integrity, authentication, right? So generally integrity means no message or an entity can be changed, right? As it negotiate from the sender to the receiver. So whenever we are transmitting some information, it should not be changed. So whatever sender has sent, it should be delivered at the destination in the similar manner, right? Authentication means before allowing a limited resource, right, or revealing information, it authenticates the sensor nodes, that cluster heads if we are using at base station, right? Then confidentiality means it to just ensure that no messages in the network are understood by the recipient, right? Also, it provides privacy for wireless communication channels such as some mobile codes, application data, and control messages, so that overhearing is prevented, right? So as you know, the they in networks we have energy limitation, right? Like sensor node has limited energy supply. Nodes may not be rechargeable, right? So energy consumption in sensing, processing, and communication. But you can see we have a lot of tasks in that we consume energy, means sensing, processing, transmission, receiving, ideal condition, and sleep condition, right? So you can identify that in transmission, a sensor node or any device consume more energy, right? So highest energy is consumed by in transmission, after that in receiving, then the ideal condition means the device is on but it is not doing anything, right? And in remaining task it is consuming very means sensors are consuming very less energy, right? So in that we have a scenario, right? So which is related to agriculture, right? So how that scenario is working, you can see we have crops and soil monitoring sensor, where some weather monitoring sensor and air monitoring sensor. For example, we have deployed some sensor for performing that jobs, right? And that information is collected by the sensor and sending that information to the some place like main sensor post, whatever we are using, we are calling that cluster head or whatever, some server we are using, right? So that node will send that information to the database server, right, for the further processing, right? And database server transmit that information to the monitoring system or whatever we are using, right? On here's analytics are performed. According to that analytics, the some instructions are given to the farmer, right? So just they are performing some real-time monitoring, right? And perform some activities according that weather conditions or crop status, right? So generally, major task of IoT in agriculture, right? So you can monitor soil moisture, temperature, controlling irrigation, efficient uses of input like water, fertilizer, pesticide, etc. Pest monitoring, then storage monitoring, tracking, right? And safety of crops from animal, right? So we can also deploy some sensors for tracking the animals, right, of the boundaries of the field, right? And if there is a animal, then they can just drop the bell at that time, right? In that you can see the another structure for monitoring the things. For example, we have some plants, right? One, two, three, and just we have deployed some sensor nodes, right? So what is doing? What they are just monitoring the plant or whatever sensor we are using. Accordingly, they will get information and send that information to the another node, or we can say that is gateway, right? So just it will aggregate that information and send that information to the remote server using internet, right? And after that remote server, whatever that information delivered to the user, right? So what devices is required for developing such type of network, right? So you can see in that case we have required for example, just we are using the soil moisture sensor. So this one is the soil moisture sensor, right? And we have required a Raspberry Pi, or if you don't have the Raspberry Pi, then you can use the Arduino, right? And one thing we have that uh, Zigbee module, right? Zigbee module is used for transmitting the data, right? So it is used for the communication type of things, right? So Zigbee is a low cost, low power wireless mesh network, right? uh, Generally used for communication, right? So it is a used always delivered a low latency communication. Latency means delay, right? So Zigbee chips are integrated with radio and with microcontrollers, right? And if we talk about the range of that Zigbee communication Zigbee module, that is the 10 to 200 meters, right? And in that you can see that is indicating the connections, right? So this one is your Raspberry Pi, in that we have connected a 9-volt battery, right? And that Zigbee module, and this one is your sensor, soil soil moisture sensor. So for connecting that thing, the cost is not too high, right? So you can connect if you are purchasing that Raspberry Pi, it is approximately 2500 or to 3000. Then for Zigbee module approximately 7-800, and that is for sensor 150 approximately, and that battery cost is 30 rupees, right? So in that amount you can easily set up a network, IoT network, and then you can get the information of the moisture, right, at your home. So you can easily build such type of things. And there are lot of videos which are available. And whatever Pi, if you are using the Raspberry Pi, then a small Python code is required, and you can easily get that small code from the internet, right, student? Okay, then come to the major research issues in IoT-enabled sensor networks, right? So generally, first is the energy, right? So in if we talk about the nodes or sensor nodes, then energy is the main constraint, right? So sensor nodes have a limited supply required to perform computation and transmitting information in wireless sensor networks, right? So generally, power failure is uh, is some nodes leads to a malfunctioning of nodes, right? Which can cause topological change and might require rerouting of packets and reorganization of the network, right? So if there are some nodes fail in the network, then such type of things will happen, right? Means yeah, if a node fail, then some information also missing. That's why that is the main issue, energy issue, right? Then heterogeneity means whatever network we are designing nowadays, it should be support heterogeneity, means multiple hardware capabilities, right? Then we have some issues in how we are collecting the data, right? How we are transmitting the data. It should be in very efficient way, right? And how we can remove the duplicate data, whatever we are capturing through the devices or sensors, right? Then deployment, how we are deploying the sensors, right? Means in deployment, you can say by using the minimum number of hardware, minimum number of sensors, we can capture the maximum things, right? We have very limited memory in sensor nodes. We have very limited space, right, for storing the things. Then how efficiently we can utilize that thing. Quality of services, then how means quality of services, you can say in some applications data should be delivered within a certain period of time, right? So from the moment it sensed, we are not delivering the data at the same time whenever we are capturing that data, right? So it depends, whenever that data is required, we need to transmit that data at the same time. If we are not able to transmit the data, that data on the requirement time, then there is no use of that, right? So we have some quality of services parameters which we need to maintain whenever we are designing the network, right? Then we have some hardware and software issues, physical attack and security, mobility, as I already discussed, means your network should be movable if we are using the mobile nodes, and for that we need to create everything, right? Then one more thing is the calibration. Calibration generally it is the process of comparison of measurement values delivering by a device under test with those of the calibration of known values, right? So whatever we are just measuring from the environment, right? And there are some standard values also there, right? So it is a comparison of the measuring values and the standard values which are available for a particular task, right? Then localization is the way to determine the location of the sensor nodes. So by using that method, we can easily find out the exact location of the sensor nodes, right? Then media communication means we can transmit audio, video, text, whatever we want to transmit over the such networks. Robustness means sensor nodes has the ability to withstand in a harsh environment. Your network should be robust. Fault tolerance, it is the ability of a system to continue operating without interruption when one or more of its components fail. Right. So these are the major issues on that we can work, right? So now we will focus on the energy issues only, means how we can save the energy of the sensor nodes, right? So these are the some methods: clustering, coverage, heterogeneity in nodes, right? Deployment, data collection and transmission, data aggregation, sync or base station adjustment, then routing. By using such mechanism, we can save the energy of the network, right? So first one is that clustering, right? So in clustering, what we have generally uh, clustering means clustering divides sensors into group, right? Such that sensor communicate information only to cluster head, and then the cluster head communicate to the aggregated information to the processing center, right? So what we are doing, for example, we have deployed 100 nodes in a field, right? And if we are receiving the information from that 100 node, right, in its control device, then every node will send that information to the control device if we are not using the clustering. If every individual node is sending that information to the control device individually, then they will consume more energy, right? So we have a mechanism that is called clustering, right? In that we set a group of devices. These group of devices will send that information to a particular device, and then that single device will transmit that information to the that control device, right? Means for example we have 20 node cluster, so they will first select a master node or cluster head. That master node will collect the information of that 19 nodes and send that information to the controller, right? So what they will help, right? So in that case, you can they reduce that cost of transmission, transmit aggregate data to the sink, useful energy congestion, then scalability for large number of nodes, and reduce communication overhead, right? Right. In that case, we are using the multi-hop concept. So in that you can see we are considering a area in that we have some sensor nodes, right? So how just you can see this one is the formula by which we are calculating the range of the sensor node, right? So we are not fixed the sensing range of a sensor node in this scenario, just we are considering the variable sensing node. So by using that formula, we are just calculating the range of a cluster head, right? So d and d max is the maximum distance between the sink and the node. That mean is the minimum distance, and base station to sensor node. So that is the distance between the base station to the sensor node, right? So by using previous formula, we have calculated that values, right? Means this is indicating that master nodes or cluster head. So every cluster head have different range. So that previous formula is designed on the basis of how means if this one x is the base station, right? If cluster head near to that x means base station, the range of that is less as compared to the others, right? If that distance of that cluster head is increased, the range or sensing range will increase, right? So that formula has designed on this scenario. So after few moments, that the cluster head collect information from the nearby nodes, right? And they will send information to the sink directly. Not every sensor will send that information to the sinks directly, but only the cluster head will send that information, right? In this you can see just they are sending that information directly, but in the next one you can see they are sending that information with the help of other cluster head, right? In that procedure they will also consume less energy as compared to the previous one, right? So again you can see the scenario how they are collecting the data within sensor, how they are collecting the data. So just that is called the chaining mode. One sensor is sending information to the another one, then next one is forwarding that information to the another one, like that. So that is called the chaining mode, how they are collecting the information. Every sensor is using the same phenomena for collecting the information from that particular area, right? So another thing is that why we need heterogeneity, right? So there are two ways for increasing the energy, right, of a network. So for example, we can add some extra nodes or we can add some extra batteries, right? If we are adding the batteries in the existing sensor nodes, then it is less costlier. If we are adding the new sensor nodes for increasing the life of the network, then it is 10 times costlier, right? So just we will add the energy of some of the nodes, but question is how we will add energy, right? How many nodes and what type of heterogeneity is required, right? So again you can see this one is the formulation, right, by which we can add the things, right? We can add the data, right, or energies, how we can count the number of nodes. I'm just skipping. So just in that thing you can see just we are calculating the number of nodes, right, and their energy, right? So number of nodes, how many number of nodes we have in the network and what will be the energy for such type of nodes, right? So we can easily calculate that thing from that particular, right? So in this scenario, just we have considered the number of nodes 100. Sync position is that 50 by 50. Then there are few more parameters which is used in simulation are given there. Then we have considered different areas like in first one we use 100 number of sensor we have deployed and they have same type of energy, means that is homogeneous network. In second one we have used two type of nodes, the energy of the 60 and 40, right? In that we have used two type of nodes. The numbers of that nodes is 60 and 40, means we have type 1 60 node and type 2 40 nodes, right? Then we have three type of nodes, means 52 30 18. Then four type of node, then five type of node, six. So in that we have different type of nodes and just we are finding the behavior after adding energy heterogeneity, because in that we are deploying 7 type of nodes by adding different energies, right? And this is indicating the energies 2 joule, zero point 0.2 joule, 4 joule, like that, right? So in that diagram, we just find out that if we are adding more heterogeneity label, then that life of the network is long, right? Just by increasing or adding the heterogeneity, we just energy that life of the nodes are increased, right? And you in that diagram, it is just identified that if we are increasing the heterogeneity, means more number of packet transmitted to the base station, means if life of the network is long, then more number of packet will be transmitted, right? Then it is just indicating the energy dissipation, how energy is consumed, right? So just indicating that thing. So in that, if we are using that 7 type of nodes, heterogeneity nodes, then it is increased, means energy is increased by 92% and lifetime is 400%, right? So means in that it is just indicate that how we are managing the heterogeneity, right? Then come to the next scenario, in that we call that coverage. Coverage means by using the minimum number of sensor, we are covering the uh, all objects, right? So in this scenario, you can see we have 4 sensors. We will consider 4 sensor and 3 targets. So by using 4 sensors, we need to cover 3 targets, right? And every sensor in that have 2 type of sensing range, R1 and R2. And you can see the relation between R1 and R2. R1 is less than R2, right? Energies is also given. Total energy of the node is 2 joule, right? If it is active with R1 range, then it will consume the 0.5 joule energy. If it is active with R1, sorry, E2, right, R2 range, then it will consume 1 joule energy, right? So in that case, you can see we have 4 sensor, 1, 2, 3, and 4 sensors, right? And they are covered that 3 sensors. 3 targets, right? So we need to find the cover set. Means cover set means by using the minimum number of sensor, we are covering these uh, targets, right? So if we are using S1 sensor with R1 range and S2 sensor with R2 range, means these are covering all 3 targets. Similarly for this one, R2 sensor is active with R1 range and S3 sensor is active with R2 range, means it is covering the uh, all 3 sensors. So these are the 5 possible solutions, right, which are covering all 3 targets, right, by the minimum number of sensors. So in that case, you can see only 2 sensors are active. In this also 2 sensors are active. 2 sensors are active. Only 1 sensor are active in that case. A remaining will be in sleep mode, right? So by using the minimum number of sensor, we are covering all the targets, right? So if S1 and S2 are active in first cover set, then energy will be update. Similarly, we can update the energy and find that network will work up to when the network energy will be 0. So if we are active all the sensors, then it will go up to the 4 times. But if we are using some sensors in a sleeping condition, that it will work for the 6 units. So in that case, you can increase the 50% time, right? Then another one is the grid deployment. This is a deployment problem, right? In that, for example, you have a field, right, in agriculture field, and you want to these dotted are indicating the targets, and we want to uh, capture all the targets by considering the minimum number of sensors, right? So we have a scenario for that by which we can choose the minimum number of sensor for covering all the targets, right? So in that there is an algorithm that is called ACO-TCAT. It is already published, right? In that how they are just calculating, mm, right. For example, here. So in that scenario, we are always start with the sink, right? Because ultimately we need to connect data to at the sink, right? So just we will we have four direction of the movement at this point, right? And we will collect that information, right? We can move means we can deploy sensors in four direction. We have free, right? So how we will move in that four direction? So in for example, in a particular direction, we will find the number of targets in that particular sensing range. For example, we are counting that number of targets in that is 1, 2, 3, 4, right? 5 sensor it is covering. Similarly, for here you will consider it is covering 4 target. So we will deploy sensor in that particular direction in which we have the maximum number of target, right? So how we will find the number of target? That is the formula for calculating the position of movement of sensor nodes, right? So in that you can see if we are using that thing in that how many sensors we have required. We have required 19, 20 and 21 sensors, right? Another in that you can understand we have used only 15, right? Similarly, we have another algorithm that by which we can deploy the 12 number of sensors, right? By using 12 number of sensor, we have covered all the targets, right? Targeted point which are deployed in a particular field, right? So in that you can say in that problem, what we are doing, just we are deploying minimum number of sensor for capturing the targeted points, right? So these are the some uh, softwares which are available by which we can perform some simulations, right? NS3 and like that. Some operating systems are given, right? Then some programming languages. So on that we can use for simulating the things, right? Then again there are some research issues, which is related to the quality of services model, right? So for example, we are right now we are using the delay packet delivery ratio and zeta type of things for capturing the quality, right? If we are we can find more quality parameters which can perform the good network in terms of good network, then we need to consider such things, right? Similarly, cross layer architecture, right? So in that security is concerned, and we need to design such type of protocols which will work for all the layers, right? Then hybrid approach, right? So we need to also propose a model which supports the hybrid architecture, right? Then we have reliability, means whatever network we are designing, that must be reliable, right? So how can reliability be achieved at all the levels of the protocol stack, right? We need to think on that. Self-powered sensors, right? Means we need to design solar sensors which can generate self-power. In that case, we can reduce the battery consumption, right? So we should protocol to be modified for time varying energy capacities, right? Then we have heterogeneous applications. Right now we have different devices, right? So every device, we are not using the homogeneous devices. Now we have homogeneous heterogeneous device. So how to ensure protocol efficiently serve for multiple applications, right? And how to make the best use of heterogeneous resources, right? So these are the still we need to work on it. Security, how we can authenticate the data, right? And can energy and security be a trade-off, right? We think about that level of security on it. right? Then actuation, right? So always actuation means sensor or network will close the loop by providing not only sensing capabilities but the ability to automatically control the environment based of the sensing results, right? So we need to think on that the current models for sensor networks may be valid, or we need to add something in that, right? Then integration with the other networks, like nowadays we have a different type of network, right? Wi-Fi, cellular network, internet. So what is the best way to interface these networks, right? Then we need to think that how any new network can interface with the existing devices or sensor nodes, right? Then the summary, then IoT enabled wireless sensor network have a bright future. Many applications have been proposed, right? There is a revolution of coming the new technologies, right? Availability of a lot of sensors which are available in the market, right? Then lot of research remain to do, like wireless networks will be evolved into traditional computers, many obstacles to overcome, right? And we need to do the practical work on such scenarios, right? So and if we talk about the in future, we have lot of technologies, and we have very powerful memories and capabilities, and these are incorporated in the sensor nodes, right? Again, that power will increase, sensor power will increase, and we need to add that devices into the different technologies for uh, improving the things, right? So that IoT enabled WSN is an enabler technology in a near future, right? Okay, thank you. Any question, participants? Yes, one student just written for the what is that Raspberry Pi and Zigbee and Singh position, right? So Raspberry Pi just like is operating system, right? By for example, if you are computer using computer, then you need to perform simple computation, right? So if we are using that, means it is just like as the mm, operating system or hardware which will be required for capturing the things. So by using that Raspberry Pi, we can connect our sensors, right? And we can connect our Zigbee module. Zigbee module is used for the communication, right? So whatever sensor is capturing the information, then it is communicated uh, using the Zigbee, right? And sync position is that like for example, you have a 100 by 100 meter area, and you have deploy some sensor nodes in that area, right? So overall, uh, who will collect that information, right? So sensor 100 sensor are deployed in 100 into 100-meter area, then that sync is responsible for collecting that information, right? And at that place where it is placed, right? It may be placed in the middle of the area, or it may be placed in the corner of the area, right? So that will be the position of sync, right? Then how does increase in heterogeneity help in improving the life of the system, right? uh, for example, in that you are using for example, one type of battery, right? So one type of battery means we have some node, 10 nodes, and every node is using 1 joule energy, right? In heterogeneous case, what is it? Some nodes are using 1.5 joule energy, and some nodes are using 1 joule energy, and some nodes are using 0.75 joule energy, right? So in IoT enabled sensor network, for example, a higher energy node will be used as a cluster head, right? And cluster heads consume more energy as compared to the other nodes, right? Means a cluster node means a master node that are collecting information from the other sensor nodes which are in the range of that. So if we are not using the higher energy node, we have only 1 joule energy for every node, then it will consume more energy during that cluster head work, and that energy will be uh, drainage fast, and it will go to the zero as compared to the 1.5 joule. So it is well proved things. If we are using heterogeneous nodes, right, then power of the nodes, power of the network will increase. Then what kind of software, hardware, and simulation we work on study to get a job in the field of IoT? Right. Initially, you just purchase few sensors like moisture sensor, soil moisture sensor, temperature sensor. A simple Arduino. It is the cost of that Arduino is 400. Sensor cost approximately 100 rupees, right? And a ZigBee module, right? You can watch some videos, right? Through that, you just start your work on that by investing 1000 rupees only, 1000 or 1500. You can just create a small project. Everything is available over the internet. By just find out the things and just invest 1000 or 1500 rupees, and you just prepare a basic model of IoT, then you can continue your work. That definitely it will help you.
Sir, as a farmer point of view,
Yes.
hello?
Yes, yes. Am I audible?
Yes, yes, sir. So as a farmer point
Okay.
of view, so do you think that is IoT can give complete solutions to say to monitor the field, to monitor the water level in the field, and even the farmer want to monitor the livestock. Okay.
Actually, that depends on the accuracy of the sensor. Whatever sensor we are using,
Yes, sir.
the everything depend on it, right? For example, if we are measuring the moisture, right, in a
Yes, sir.
field, then what is the accuracy of that particular sensor? It depends. Everything depends on the accuracy of the sensor. Nowadays, we have very powerful sensor, right, and they are given a very good information.
Sir, but if you see the climate condition, hot and wet, etc., raining, so there is a chance, a lot of chances of possibilities of damaging the sensor. In this case, what is the best solution?
Right now, because we are not gathering information through a single sensor. In such applications, we are gathering information from multiple sensors,
Yes, sir.
right?
Yes.
And these sensors can work in a very harsh environment, right?
Oh,
If few sensors are not able to gathering the information, then other can do, right?
yes, sir.
Actually, the modes and sensors are same. There is no difference.
Okay, sir. Okay. Thank you,
And
sir.
one more question is that clustering method. There are a lot of clustering method nowadays. We are using the meta heuristic algorithm for performing the clustering, right? So as such, we cannot say that method is the best, but we have thousand methods for solving the clustering problem.
Sir, algorithm wise, it's okay, sir. But a practical point of view, say I want to monitor. So sitting in my home, I want to monitor. So what is happening in the field or in the garden? So in this
Yes.
case,
For example, you are sitting at your home
yes,
and
sir.
you are just capturing the your information from your field, right? So you
Yes.
how you will get the information? You will get that information through some application on your
Yeah.
mobile,
Yeah, definitely. Yes, sir.
right?
Yes.
And for that you need to perform some calculation based on the gathered information, right? So
Yes.
means whatever a sink is there, means a cluster head or a controller is there, based on the parameters which are received from the field, they will perform some calculation, and that calculation will be based on that captured parameter. Accordingly they will means that system will inform you.
Is there
Right?
any recommender system is available regarding to monitor?
No. That system will be managed by you initially.
Okay.
Right? Actually, there is no fixed thing. For example, just a sensor is capturing some information, then it is passed to the server. Then server performs some analytics. And how they will perform the analytics, you need to train that thing. You will perform some calculation, but initially you need to put some inputs for how they will perform the calculation. After that, you will get the information.